Viewers, my name is Emmanuel. Welcome to Ndubisi Online Math and Physics. In this video, we are going to continue on where we stop on indices. We have discussed many laws of indices. I think we have discovered 7 laws. We have discussed it. We are still on the law. Don't forget that. Law of indices. Law of indices. So we are still on law of indices. We have discovered and discussed multiplication law. We have discussed division law. We have discussed power law. We have discussed product power law. We have discussed zero index. We have discussed negative index. We have discussed root power and fractional index. Now we are going to this the last law that we are going to discuss under the law of indices, which is what? Exponential function. Exponential function. Exponential function. Yes. Now, this is one of the law of indices that deals with index forms. Index forms of perfect square. So it deals with index form of what? Perfect squares. The reason why I'm splitting this into segments is that for learners to gain massive understanding on these laws. It's not just about teaching, it's about understanding. So now let's continue. Exponential function deals with what? Index forms of perfect squares. Now let's start from 1 because we know that 1 is a perfect square, right? Yes. Now let's start from 1 as a perfect square. What are the index form of 1? The index form of 1 is what? We have 5 raised to the power of 0 because you know that any number raised to the power of 0 becomes what? 1. You can say 5 raised to the power of 0, even 1 raised to the power of 0, 2 raised to the power of 0, 3 raised to the power of 0. So any number that raises to the power of 0 becomes 1. Is that clear? Now, also we have 1 raised to the power of 1 because you know that 1 raised to the power of 1 is what? It's 1. Even 1 raised to the power of 2 and all of that. So because 1 times 1 becomes what? 1. So but I'm going to advise you to make use of this if you are dealing with this aspect. So you make use of this, especially this zero index aspect. Now let's look at 4 because 4 is what? Is a perfect square. Then how do you know perfect square itself? You start from 1 times 1, you give 1. The next number is 2, right? 2 times 2. Just be multiplying them together. Now 2 times 2 gives 4. That means that 4 is what? A perfect square. Now the index form of 4 is 2 squared because we multiply 2 in 2 places. 2 times 2 gives 4 as a perfect square. Then what should be the index form? The index form is what? 2 raised to the power of 2. That is the index form of what? 4. Now 3 times 3 is what? 9. 9 also is a perfect square. Then the index form of 9 is what? 3 raised to the power of 2. Now we have 4 times 4, 16, right? So we have 4 raised to the power of 2, which is what? 16. And also 2 raised to the power of 4 is what? 16. So in this exponential function, it deals with the index form of perfect squares. We are going to know them. Some are not even perfect square, but you have to know them. Like example, 8. 8 is what? Index form of 8 is what? 2 raised to the power of 3, right? 32, 2 raised to the power of 5. So you have to know this. They are not perfect square, but they have index forms. Is that clear? So now you are going to note this very well. It's very, very important. And coming to here, 5 times 5 is what? 25. So you have 5 raised to the power of what? 2. You have 5 raised to the power of 2. Now coming to here, 6 times 6 is what? 36, right? Yes. So you have 6 raised to the power of 2. That is the index form of what? 36. 7 times 7. That is what? 49, Abby? Yes. So you have 7 raised to the power of 2. The same thing, 8 times 8. You have what? 64, which is what? 8 raised to the power of 2. You can also say 2 raised to the power of 6. You can also say 4 raised to the power of what? 3. So give you 64. Now, 9 times 9, 81, right? So 81, you can say 9 raised to the power of 2, we give 81. 3 raised to the power of 4, give what? 81. So, and so forth, etc. So that is what we need in this exponential function. And see how they ask the question. They just say 5x is equal to 25. Find the value of x. 5 raised to the power x is equal to 25. Find the value of x. See what I'm going to do. What I'm going to do is that this is what the left hand side, right? This place is right hand side. So this place is what? Right hand side. This place is what? Left hand side. So what are you going to do that the base of the left hand side will be equal to the base of what? Of the what? Right hand side. What are you going to do? So what I'm going to do is just to find the index form of what? The right hand side. So what is the index form of 25? The index form of 25 is what? 5 raised to the power of 2. So you say 5 raised to the power s is equal to 5 raised to the power of 2. You can see that the base of the left hand side and the base of the right hand side is the same thing, right? So that is why we need to know index form of perfect squares. So it is very, very important. Now, so you can say this cancel this, then s will be equal to 2 because when the base are the same, they are the same, and what connects them is what? Equal sign. So their power will what? Be the same. So their power is what? S equal to what? 2. So this becomes the answer. Because you know that if you don't know the index of 25, you can't solve this. So you have to make sure that the base is the same. What can you do to 25? What can you do to 25? That the base will be equal to the what? Left hand side. So you have to do something to this 25 so that the base will be equal with this one. Is that clear now? So if you really enjoyed this video, please, as I've said earlier, do it to like, comment, and also share. Subscribe for more videos. Thank you. God bless you.